Alright, another day, another coding challenge. This stream is for entertainment purposes only. And let's continue our sufferings with this random generator that will again give us the hard problem. That's my feeling. Seriously? Oh no. Oh no. Again. Permutation sequence. This set. Okay, so with the hard problems, we will try to at least come up with some algorithm under 40 minutes, and then debugging may take an hour. So just to pass few tests, that not all of the tests, but okay, let's see. The set contains a total of n unique permutations and factorial unique permutations. By listing and labeling all of permutations in order, we get the following sequence for n. In order, so 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Given n and k returns k permutation sequence. I don't, I don't even know. Well, so technically, all right, so let's return to this interesting example, right? And that we have at part 1. Let's switch to the whiteboard. So so we have these 1, 2, 3, right? 1, 3, and 2. Two, 1, 3. 3, 1, 2. No, 2, 1, 3, 2, 3, 1, right? And then 3, 1, 2, 3, 2, 1. So given the n, right, we know so we start with the first digits, right, with the first column. Given the k equal 4, right, which is this one, we keep counting numbers So interesting. So how do we know how many permutations are in the rest of the tail, right? Because 2 factorial is 2, right? So it's n minus 1 factorial if we shift one thing on the left, right? And this thing will repeat n times for every number 1, 2, and 3. This is clear. What is not clear is that how the k will correspond to the number itself. It's more like a math problem. There is no much of the algorithm, I believe. Right, so related topic, I guess, is just math and backtracking. Yeah, that's my feeling, that we need to use some sort of recursion here. So we can do k percent n, all right? In this case, if k is 4 and n is 3, then 4% 3 is 1. What does it mean? Do we need, no, sorry, not percent. So we can check if k is less than n minus 1 factorial, then we know that the first number is 1, right? So if it's 1 or 2, then less or equal to, right? Then first number is not changed. Otherwise, it will be the heck, let's say we have 6, k equal 5, right? And n minus 1 factorial is 2. Is it k divided by n? K divided by n minus 1. Then we subtract from k n minus 1, right, to recursively, co-recursively. And at the So all right, so factorial of 9 is not the big number, so we shouldn't worry about the size of things. But here is the idea, right? So this is what we do. So if k is 4, right, n is what, 6, so it's 5. 4 divided by 5, 0 minus k. We don't subtract anything. No, it's 2, right? Exactly, it's 2. So if k is less or equal to this, we use 1. If k is greater than this but less than 2 of n minus 1, this is 2, and so forth until the n factorial, right? And then what we do, we recursively call it again to select the next number. All right, so here we go. Let's say int n factorial, all right, which is equal to 1. And therefore int I equal 1, I less or equal than n, I plus plus. So we calculate the initial factorial. So we know that n is less or equal than 9. So factorial of whatever is given should be, so int should be sufficient, right? So we say n factorial times equal I. All right, and then we have internal method, let's call it private method, of string get kth permutation int n int k, and let's say int n factorial, right? Do we need n or do we? Yeah, we. All right, let's see. So what do we say? So basically, what we want to say is right, if k is less than 1 times n minus 1 factorial, right, or 2 or 3 or 4 or 5, then we figure out these number, right? So we can say while we start int let's say I equals 1. We always start with 1, right? So while k is strictly greater than I times n factorial divided by n. This is basically n minus 1 factorial, right? So in the worst case, I becomes equal n, and then n divided by n is just n factorial, and k by definition should be less or equal to n factorial. So we will stop eventually. I plus plus. So once we stop at I plus plus, k is greater than n factorial. So what we say then, two things. First, we want to subtract from k, so we say, right, so we say return, right, what, to string I minus 1 plus get k permutation where n becomes n minus 1, right? And then if n equals 0, then we return its empty string. So k minus what? Whatever here, right? So 1 times this, right? This is for k. We subtract this thing. And n factorial becomes n factorial times n, right? Maybe we should do I plus plus while this, right? And I can be from 0 actually. So we add 1 we check if k is greater than 1 times n factorial by n, and we actually can say this like this, right? So n factorial times equal n, right? So we do just this just once, and that's it. And then we just use this thing, right? Then we add string here with whatever it is. So let's figure out in our forgot to switch this thing. So let's figure out with our example one more time. If right, so let's consider this. So okay, we got this factorial of 6, right? We have this 6 and k4, right? So factorial here, so this will be called with 6, 4, and then factorial is what? Sorry, n is 3. It's 3 and 4, and n factorial is 6, right? So n0 no, so n factorial becomes what? 6 divided by 3, which is 2, right? We start with n, so we start here 1. So here 4 greater than 1 times 2, true. Right, so we do one more time. So we increase I to 2, and then two times 2, should it be greater or equal than n factorial? Or whatever, we maybe just don't need to subtract it, right? So that's what we say. I permutation I factorial. Right, and that works way better. Let's see. So (2.2) and definitely 4 not greater than 2.2. Or better to say this, right? Is not true that this is the case. So we stop at 2 here, and our first string will be 2. Then we call this function. Now second time, right? Second time we call it with n minus 1, which is 2. All right, k minus I n factorial, which is 0. All right, this is bad. If it's 0, then what? Then whatever left unused until string is fulfilled, right? We just add them in order. So we need to say used integers or whatever characters. You basically can say vector of bool here, right? Used, it will be of what? Of n size, right? And false at the beginning, so we use vector bool used here as reference, So this I that we used, right? Factorial, then we say used, and basically I minus 1 because it starts from 0 numbering equals true, right? And if it's 0, we basically say what before we return? We basically go in order for, oops, let's say int I equal 1, again I less equal n, I plus plus, right? Green press, then we say if used I minus 1, if not used, right, we say res plus equal to string I, and then we return res, which is by default, let's say this one. All right, so should not work. But my feeling that we should subtract just 2 from first k, right? Because we said the ones are not, then maybe it is this one, right? I is what we're using to string, which is 2, but we subtract 2 from k, so we call second time 2 for n, 2 for k, and then factorial is also what, 2. So we call it with 2's. So then factorial becomes 2 divided by 2, just 1. Alright, and we say again 1 by 1, k is 2, k is greater. Then we say 2 it's not just I itself. So it's okay for the first time to be just arbitrary number, but technically what we want is just the cycle, right? Let's do the same sort of cycle here. So let's say we have this cycle instead, right? So we start with I equal 1, and what we say is it should be unique CMT, okay, unique CMT equal, let's say 0, whatever, right? So if not used, then we say unique CNT plus plus, right? And then we say not used, and this thing, right? Then we have this I. And it's not and, this is K, by the way. And before we break, we need to assign this to something. Let's say int next to 0, then next equal basically I, right? And it should be greater. And then we can safely remove this thing and this thing. Right, so basically we go through the same cycle again. So let's see, we start with 3, 4, 6. So we go from 1 to 3 here. Obviously nothing is used at the beginning, so we just increment it. So basically unique count will match the I almost. Alright, so we add one element here. So unique is 1, so we check if k is greater than 1 times n factorial. If not, then we go to the next element and check. And in this case, for 1 is not greater, for 2, so the second unique element, times n factorial, which is what at the beginning we divided it by 3, so it's 2. 2 times 2, k is not greater than 2 times 2, right? So we stop. Okay, so now we know that the first element here will be the second unique element, and the second unique element in the first case will be 2. All right, and it won't be I minus 1, it will be next minus 1. Next minus 1 equal true, right? Because we used it already. And then we say to string next plus get k's permutation, where now we need subtract from n1, from k we need to subtract next minus 1. And it's 1 times n factorial, which was already divided by 2. So it's 2 times, because we took this second unique element, so it will be 1. Or will it be next at the count? I think it should be the count, right? It should be unique count. So the second unique, right? So yeah, correct. I'm saying factorial and then n factorial. So we have these 2, 2, 2 now, all right? So factorial is 1, and again, here we go. We go 1, is it used? No, all right. 1 times 2, because unique element now is 1. And case 2, is it greater? But case 2 also. So, but then factorial is 1. 1 times 1 is 1. 2 is greater than 1. Once it's less or equal to. Okay, then this one. So, but 2 is not less or equal to, right? So we had to go to the second unique element, which in this case, we skip 2 because we already used 2. It will be 3, all right? So we go to the 3, and 3 times 1 in case 2. So obviously k will be less than the 2. So we will subtract whatever left from so we subtract, all right, so the 3, right? So 3 times 1 is 3, 2 is less than 3, so we say that next is 3, right? We set 3 to true, so we used it, and we now have 2 and then 3, right? And this is correct so far. Now we call n as 1. All right, because it was 2. K will be minus unique int minus 1, which is again 1 times 1. So 2 minus 2 is 1. All right, so we really go very tight here. 1 unique element 1 for k, and n factorial is also 1. Interesting. And whatever used r, right? So we don't care here. Right, let's see how the algorithm performs in this corner case. So if to me, if k is 1, it's just basically first unique element left, right? If and n is 1, so it's like the last whatever element left, all we need to do is to say, right, so n equals 1, we just go basically no, that happened. We just go basically this, once not used, return to string I. That's it. And that's it. And we start. So in this case, we then 1, 1, 1, say 1, and the only element not used is the first element. So we will return really just 1 here, right? 1, and as a result, we return 2, 3, 1. All right. Let's see if it works. Obviously it won't, but and we're running out of time, so we just have time to debug it basically. And obviously we need to return something here. Get case permutation. We start initially with just n, k, everything is great, and factorial, and used. Run the code. and obviously we want to have space here. Alright, something wrong with the addresses here. So next, -1 is bad for some reason. Interesting. It's always between 1 and n, and it's n, and here's false. Let's just print out cout n equal to n, k equal to k n, n factorial equal to n factorial, right? So this is sufficient information to give us some hint what's going on. Basically, run the code. So this is exactly what had happened, right? The only difference, we started with 3, not 4, but whatever. Then we get to 2, 1, and 2, which is correct. Then we get to 1, 1, and 1, which is correct. So if not used, return to string 1, and you should say else. We do this thing. So now the only difference, what do we return at the end here? It should never happen, but it will complain if we won't do anything. So let's return the empty string. So I wonder what's wrong with that. 2, 1. It doesn't return the last element. So if it's returned 2 and 1, then obviously it should return this one. I don't understand. If I minus 1 not used, return to string I. It's basically the only element left that is not used. Am I missing something? Alright, let's bring this cout I equal to I used equal to used I minus 1, and then version basically returning the empty string here. I don't understand. One use and then it stops. But why? Is it the cycle? Why does it stop? I don't understand. Let's say next. Get on driven development. So it says next one. So it just should find the tree. What the heck is wrong with that? I don't. Oh man, do we break a cycle or something here? No, we return to string I. If used, true. If not used, we return it. Used, it says 1. So it should go here again and start with 2, but it doesn't print 2, which is weird. Why it doesn't print 2? Oh, because it's the n that we subtract, right? Oh, it's wrong. It doesn't work as it should be, I guess. It's correct that we divide it here, but we should always go through unique elements here, right? Or we can just say actually used. Yeah, we don't need this. Used, we have this. Size. That's what we need. Don't need your and here we need this one. Run the code, and now everything will work as intended. Used 0 and then result 213. All right. So let's see how many tests we're going to pass with this kind of algorithm, if at all. And then see what happens. One more time, run the code. Everything works fine. Yes, submit. We passed the hard problem today in under 40 minutes with the debugging. Almost with the debugging. Okay, debugging is off by roughly 7 minutes or so. And it's awesome. Can we save a little bit on something here? Well, maybe we can save a few megs in memory. But I like it. It's 0 milliseconds, 6.9 seconds. Oh my gosh, for the hard problem. The hard problem, we did it. Let's submit a few more times to get the better scores. I guess I would just leave it as is. I don't want to mess with memory or something. Okay, I'm taking this. I don't want to see if there are any better scores we can get. We have 0, so it's 100 scores for the time complexity. And by the way, the time complexity is, we go n times here, right? And within these n times, we go through n elements here. So it's technically quadratic, which is fair, and space is basically linear, because we only track the linear right here. All right, works for me. So let's switch to the whiteboard, and oh man, feel good about watching fireworks today, because we solved hard problem under 40 minutes. So, and we basically didn't use hints, so there were no hints, just the topic that this is the mass and backtracking. It's not like the huge hint. Alright, so the total is 183. yeah, we just have it. Cool. So let's switch to the default scene, go to YouTube channel and see fireworks. Fireworks. I already saw it. Fireworks. Something cool here. And of course we need to watch the ad.
Purdue University Global. Apply now at purdueglobal.edu.
Come on! Where are the fireworks? Done it. So with that, see you hopefully tomorrow. Bye.